Hello everyone, let's begin with the question. And in the question, it says that a small ball of mass small m and charge small q is attached to the bottom end of a piece of negligible mass thread of length small l whose top end is fixed. Now, the system formed by the thread and the ball is in the vertical plane and is in the horizontal uniform horizontal magnetic field which is perpendicular to the plane of the figure and points into the paper. That means this we can see that there is a magnetic field here that is inward to the paper, and here there is a mass, very small mass, which is having, I think, velocity here m, velocity v naught, mass m, and charge q. Now what it says further, that ball is started. The ball is started with a velocity v naught from lowermost point. So from this point, it is started moving with velocity v naught, the lowermost point of a circle, in a direction perpendicular to both the magnetic field and to the direction of the thread. So here it is, tangent is perpendicular, so it is perpendicular to the direction of the thread and the perpendicular to the direction of the magnetic field. Now the ball moves along a circular path such that the thread remains tight during the whole motion. So neglect any loss of the energy. So what will be the magnitude of magnetic induction, where the minimum velocity at which the motion can be described is v is equal to 1 by 2 root 17 gl. So let us solve this problem. So what we assume, that suppose during the motion the ball has moved from the point C to moved and come into this position. Now during this motion, if we say, let's say this came into this position. Now during this motion, when it reaches here, its velocity will decrease, because when the ball is climbing up and up and up, its velocity will decrease. So at this point, let us assume that the velocity is v. So velocity is v, and if we can say that this is angle theta, then this height will be equal to L minus L cos theta if the length of the string is L. So now we are interested to calculate the velocity v in the form of v naught. So by using third equation of motion, here v square will be equal to v naught square minus 2 g L minus L cos theta. So this is the value that we have. When we further simplify and put in the value of v naught, now we have v square is equal to 17 by 4 gl minus 2 gl plus 2 gl cos theta. Now from here we calculate the value of v, and that will come out v is equal to 3 by 2 root of gl 1 plus 8 by 9 cos theta. So this is the value of v that we have obtained at this point, which is this one. Now what we do now, we will apply the force balance equation. So if you see that the at this point the mass will act in the downward direction, and since at this point the direction of the velocity is into this direction, so by right hand rule, the force here, the force will act into this direction, that is the magnetic force, and its value will be qvb. Now if this angle is theta, this angle is also going to be theta. This is mg, this is qvb, and this is tension force. So this is mg, this also mg having two forces, one in the vertical direction, this is mg sine theta, and in this direction also we have mg cos theta. So now we write down the equation of centripetal force. Here the equation of centripetal force will be T minus mg cos theta minus it is magnetic force, that is QVB, and this will be equal to necessary centimeter force, that is mv square by L. Okay. Now when this particle moves and it reaches at the highest point, so at the highest point the tensile force will be 0. So at highest point, t is equal to 0, and in that time period theta will become 180 degrees, so cos 180 degree will be equal to minus 1. So what we do now, we use this, say this is equation 2 and this is equation 1. By using this we can calculate V and magnetic field. So V will be equal to, in this case, if you put cos theta here, minus 1, so this will be minus 8 by 9. So 1 minus 8 by 9 will be 1 by 9, and when it comes out it will be 1 by 3. So 3 and 3 will be cancelled. So V is equal to GL in the root by 2. Now here tension force will be 0. From this expression tension force will be 0. So tension will be equal. So from here magnetic field QVB will be equal to mg minus mv square by L. Now further B will be equal to mg by Q into mg by QV minus mv square by QVL. Further, this is mgl by QV, and we put the value of V square only here. So here we have mgl by 4QVL. So from here magnetic field will come out as 3 by 4 mg, this is L here, so mg into, we obtain here mg by mg into 1 by 2 Q into V. Now V is root GL by 2, so magnetic field value will become here is 3 by 2 mg upon Q into root GL. So this is the final value that we have obtained in this question. Now when we move towards the option and check with the values, we can confidently say that the option 1 is the right answer of this question. Option 1, which says that 3 mg by 2q into gl, that we have obtained in the end. So this is the right answer of this question. This is about this question. Thank you for watching.